This is the Malta power plant, and it produces electricity for hundreds of thousands of homes. Very nearly journey's end for the water, 22 kilometres from the dam to here. The drop has increased the pressure 6 times over as it makes this last right turn into the turbine hall, which is where I'm going now. Right, how do I get into the turbine hall? This is where the magic happens. 4 giant turbines harness the raw elemental power of the water hurtling down from the dam. One of the turbines has been shut for maintenance, so I'm being given a very rare treat, the chance to climb inside and see its inner workings. So the water roars in through each of these 6 nozzles. Deflectors in front aim it into the right place to hit the buckets. Set this wheel spinning, 500 RPM. Sets the shaft spinning, and from there, they create electricity. Responsibility for keeping the turbine in tip-top condition lies with Walter Staudacher, and for today only, me. This is where it all comes together, and at this point it suddenly becomes about absolute precision. The precise design and shape of these buckets enables them to harness as much as 92% of the energy from the water. Talk to me about the splitter, the bit in the middle. How much?
Yes, the splitter in the middle. There the water jet is cutting into 2 pieces. You know, like a knife at home, it had to be sharp, otherwise you need a lot of force.
So I've got to sharpen the splitter?
Yes.
I've never said that before.
Here, that's now running, that's the grinder. Put on your eyes, and then you start grinding up here. Here, go.
Oh my God, this is right at the heart of the machine. All the effort we've seen so far hangs on what happens there. There is a very good reason why the buckets on this turbine wheel are this shape. If you had a single scoop, the water would come in here, hit it, turn the wheel, that's good, but then some of it would splash back and hit the bucket behind. That's inefficient. This is about controlling how the water gets out as well as how it gets in. With the splitter in place, water comes in, hits it, pushes the wheel, but then is sort of scooped straight out in 2 even streams. It's efficient. That's how they get to 92% efficiency here. The reason this has to be sharp, and why I've just been sharpening it, I can demonstrate with this. Here's my bucket, my scoop. Here is the splitter, nice and sharp. And here comes my flow of water fresh from the dam. And as it hits, the splitter is dividing it between the 2 sides of the bucket. And that's not bad. I've lost some ping pong balls, but they've ended up pretty much evenly distributed between the 2 sides. Maybe we've got 92% efficiency there. Right, we can reset and demonstrate how it would work with a less sharpened splitter. Right, so all I'm doing is turning this over. It's got a blunt edge, it hasn't been sharpened. Same process, switch on, water coming all the way from our dam, hitting the bucket at the very end, and it's a disaster. Every ping pong ball flying away is more water not being used to push the turbine wheel. You won't stand a chance of hitting 92% efficiency. And now we've got to tidy up their turbine hall. Sorry. Above the turbine, where the water hits the buckets, is the generator, which creates the electricity. And they're connected by a massive 25-ton metal shaft. Wow! I'm sitting directly above that turbine beneath me. It's turning as the water pushes it round. This is the output shaft. And that means the turbine has done a very clever thing. It's turned linear motion of the water moving along into rotary, circular motion. In the old days, that would be a water wheel. You'd use this to grind corn or even sharpen knives. Here, they're using it to make electricity. And how they do that is pretty simple. This is in miniature what's happening here. It's a bicycle dynamo line. And if I persuade it to come apart, you'll see that when your bicycle wheel turns this shaft on the end, This shaft on the end of it is a magnet. Magnets are funny things. Move a magnet around a conductive metal like copper, and it moves tiny particles inside it, electrons. And moving electrons, that is electricity. And so if I reassemble my little dynamo here, I'm going to see if I can use a bit of their power to make my own. I'm stealing their power. So that is water from the dam turning that gigantic turbine to turn both the enormous generator above and my tiny bicycle one here and light this light. I mean, it would be a lot of trouble to go for if that's all it did. It's on a bigger scale than this. And so we come to the final part of the process, getting the freshly made electricity to homes all over Europe. And this is the control room which makes that happen. Everything we've seen so far, every drop of water and of sweat, if you like, ends up here. This is the place where big just got bigger. The Kölnbrein dam we've been looking at is there on this that charts the whole network. And as you can see, it's just one remote corner in it. That's how big this network is. And the water flows along the pipes, as we've seen, to the turbines. These are the ones here, one of which I've just been in. And ultimately, the end product is, they call it, from water to wire, because it goes from water, as we've seen, gathered behind dams like the Kölnbrein, along the pipes, down to the turbines, and then it leaves here on the wire. And there is the wires, and it's gone, turned into power.